we are going to be finishing up 10.1, which again was about sample spaces and just overall probabilities. So we've talked about theoretical probability, and we are also going to talk about geometric probability. So geometric probability is just where you take the ratio of a specific portion of something to the ratio of the whole thing. So let's take a look at our first example. So we are given this picture over here. This is super critical. So it says, you throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. So that's just meaning there's no, just disregard the fact that there's wind resistance, gravity, all that stuff. Okay, so you're just thinking of your perfect shot. Are you more likely to get 10 points or 0 points? Okay, so this is where we're going to have to come up with some type of way of looking at the probability of these two events. Okay, so first off, to find the probability of landing in the 10 area, so this area right here, we're going to look at essentially a ratio of the area of just that small circle compared to the area of the entire board. Okay, and I like to write this out in words before I plug stuff in, because it allows me to constantly think about what am I doing as I go through this. So now, if you don't remember, area of a circle is pi r squared, where r is your radius length. Now here it tells me this is 3, okay, so that arrow is implying that this is 3. Okay, so I have pi times 3 squared. Okay. On the bottom, though, is the area of the entire board. So area of the entire board is a little bit harder because it's not, or it's easier but also harder just because they didn't give us a whole lot of information. So if this is 3, change colors real quick. Boop. This is 3, and this is 3, then that makes all of this be, so 3 plus 3 plus 3, 9. Okay, so since this is a circle, this means that that's our radius, right? And radius is half a diameter. And so if this is 9 and 9, this makes the entire side length be 18. Now, just because of the fact that circles are the way that circles are, if I were to take this and look at, it this way, let me go ahead and bring it down. Okay, my side length is also going to be the same, just because of the fact that a circle has a radius that's the same this way, so long way, and so horizontally and vertically, right? That's kind of the whole concept of circles. All right, so as we said, by knowing that information, now we know that, now we know that this is 18, and also this distance is 18. Okay, and to find the area of a square, we just take length times width, or base times height, whatever your heart desires. So this is just going to be 18 times 18. Alright, so let's go ahead and just plug in some of that information just to kind of simplify it out. So 3 squared is, so again, this is still the probability of finding how likely are we to land in the 10-point area. So 3 squared is 9, so I get 9 times pi. 18 times 18, I plug that in my calculator and I get 324. Okay, then again, I plug this into my calculator and I want to make sure that the top is in parentheses. And then I get 0.0873. Okay, so again, personally, I like to look at the percentages a little bit better. So moving this percentage to, or this decimal to the right, 2, 1, 2, we get 8.7%. Okay, so I have an 8.7% chance of landing on the 10 circle. Okay, so now the next thing it wanted me to do was it also wanted me to compare it to the getting 0 points. Okay, so real quick, I'm just gonna clean this off just a little bit so we can see it a little bit better. So looking at the 0 portion, so 0 is all of this stuff, this light blue stuff outside all of this. So it is essentially the entire board excluding the portion that is inside the small circle. Or I'm sorry, the big circle, the big yellow circle. I wish that I could draw a straight line. There we go. Alright, so how I'm going to go ahead and set this up is I'm going to take, again, this is just notation for saying the probability of landing in 0. Again, we write this out because of the fact that to our reader, it's super critical to tell them, hey, this is what I'm finding right here. So, P of 0, I'm just undoing that because I'm going to need that space. So P of 0 means I'm going to take, so I know I'm going to compare it to overall the total board. But on top, as I was saying up here, again, we're looking for just this blue area. So it's essentially like taking the area, so to find just the area of the 0, what we're going to have to do is we're going to have to take essentially the area of the entire board, and subtract the area of the big circle. So this is essentially like we're finding the complement in a way. So we've got the probability of this. So the area of the board we already talked about is 18 times 18. Okay. Now the area of the big circle, well, the big circle is this entire thing, which does still have a radius of 9. Okay, so we're going to do 9 squared times pi, because that's the pi or squared bit right there. Okay, again, this is area of the entire board. This is area of the big circle. Now again, this is all over, essentially, that still area of the board. Again, I already found that this is 324, this is 81 pi, 324. So go ahead and plugging this in. So again, I plug this in using parentheses on top, and I get, and parentheses on the top here is super critical. This one is, you have to put parentheses or you're going to get the wrong answer. So I get 0.215. Okay, so that, as a percentage, is So if I move the decimal 2 places to the right, 1, 2, I get 21.5% chance of landing on 0. Okay, again, so looking at this, you know, if we're just assuming that the board entirely is just as likely to fall in any place as any other place, no matter how good of a shot I am, then we can compare the two. So this has, it only has a 10, or I'm sorry, not a 10, an 8.7% chance of landing there. But the outside, so this portion here, in case you can't see my cursor, let me go ahead and change this. So this side, this stuff, and this stuff is 21.5%. So that means that you have a better chance of landing on 0. Okay, again, this is to answer, are you more likely to get 10 or 0 points? Okay, so remember, when we're answering these questions, yes, they are easier, but you need to answer in a complete sentence. So that is that one. Now, real quick, I just wanted to talk about some of these other types of problems that I saw, and I know you probably already did a few of them for your homework. Again, they're just setting up using the equation for P of A, or probability of the complement of A. Remember, this just means complement. Okay, so I'm going to take 1 minus whatever my P of A is. So for example, for the first one, P of the complement of A is going to, the probability of complement of A is going to be 1 minus 0.45, which is 0.55. Okay, just to show you, in case you were confused by that. All right, our next type of probability is experimental probability. So experimental probability is really where you take theoretical probability and you go ahead and do trials or something. So as I said, experimental probability is based on repeated trials of a probability experiment, such as rolling dice, flipping a coin, picking a card from a deck. Okay, so the number of trials is the number of times the probability experiment is performed in total. Each trial in which a favorable outcome is called a success. So these types of words here and here are important. Okay, now most often when I see experiment, I think of science. Okay, because that's really what science is. It is taking our theoretical probability and proving it in a way. And the reason why theoretical probability versus experimental probability can differ is because of the fact that we have a lot of things overall in the world that can affect things, such as gravity, friction, just depending upon what it is, you know, maybe poorly made, maybe something like that, that can change what it is. So that's why experimental probability is so critical, because theoretically, yes, things should work in a specific way, but once you actually look at the fine details of this, you can truly see what the nature of that probability is. All right, so we have example 5. Each section of the spinner shown has the same area. Okay, so it's just essentially saying that they're all equal parts. Spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? Okay, well, first off, the theoretical probability. Okay, theoretical probability is just saying so if any one color is equal to the number of slices versus how many total slices. So 1 in 4. Okay. Now the experimental probability is really where we're going to use this stuff. Okay, so we're looking for which of our experimental probabilities is equal to 1/4. Okay, so I'm going to just start with yellow. So I've got yellow. Oops, I meant to put a P first. So probability of yellow. Okay, so this is going to be the number of times that they spun yellow and our total spins. Okay, so the number of times they spun yellow was 3, and the number of total spins was 20. Okay, so 3 over 20 doesn't simplify, so that is our probability of landing on yellow. Let's try probability of landing in blue. Well, that is also going to be the number times spun and lands on blue, total spins. That one's also 3 over 20. Sorry, my computer's trying to catch up to me. Alright, so last one, and I went too far down because I'm going a little crazy. The probability, or no, this isn't the last one, we got one more. So this is 9. Oops. So again, I'm getting these numbers from right here. So we landed on it 9 times to 20. Okay, again, that's number of green versus total. Is 9 to 20, and that does not simplify. Probability of red is equal to 5 over 20, so the red total was 5 over 20, which is equal to 1/4. Alright, so this means that which color is the experimental probability? The same as theoretical. So red has the same experimental and theoretical. Sorry, it's delayed a little bit, so okay. So why would they be different for these other ones? Okay, well, if you've ever played a game, like a board game with a spinner, you might have noticed that sometimes it falls more on one slice than another. Okay, sometimes that's because of the fact that the board itself is uneven, or maybe the arrow is broken and kind of like, tilted, or sometimes the overall board is bent, or even sometimes you think they're all the same size and they're not. Now in this case they were, but sometimes other weird things can happen. Alright, so that's for our first problem for experimental probability. But we also have this one, and this is kind of more like what we'd see if we were to be looking at probability in the real world, where we've got some data and we're just going to relate the data. Okay, so in the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them had at least one pet. The types of pets these adults have are shown in the figure. So right here. What is the probability that a pet-owning adult chosen at random has a dog? Okay, so there's a couple parts to this. One, the first part is the fact that it says, what is the probability that a pet-owning adult? Okay, so what that means about this is it means rather than taking it to the total number surveyed, it's saying it's the total number of surveyed that have animals or that have pets. Okay, so not this total, but this is the one that we're going to use. So the 1328. Okay, so now on top, we're talking about the probability that a pet-owning adult has a dog. Okay, so that's 916. So total number dog people. Okay, so 916 compared to 1,328. Okay, you can go ahead and either simplify it using your calculator if you'd like to. Okay, so this is 229 to 332. So 229 own dogs to 332 pet owners. Or we can go ahead and write this as about 0.7. Okay, so we can say that the probability that a pet owning it needs to catch up again. All right. So that a pet owning adult has a dog is 70%. Okay, or you could say 0.7. Okay, so 0.7, 70%. Again, either of them work. I wouldn't mark you down, but generally this is what I prefer to see, just because for me, it's easier for me to understand it that way. Because for this, my brain still has to go, okay, well, I take the decimal, I move it 2 places to the right, and then I get 70%. And that's just too much for my brain to think about. So, and also most likely it'll be written in percentages on the test. Okay? So I hope you had a great long weekend. Your homework will be posted, I believe it's 13 through 20. But it will also be posted on the Google Classroom. And I hope that if you have any questions, feel free to email me over Remind or on my email itself. Thanks, have a great day.